Okay, today we are going to talk about two words again, um, distance and displacement. Okay, so to understand the difference between these two words, what I'm going to actually do is draw a track. Okay, so here we go. Got our track, and let's put a person on this track. Draw our starting line, and let's put our person right there at the starting line. Okay, and let's say that this person now ran all the way around the track once, right? And I asked you the question, how far has this person gone? Well, you might answer, well, they've gone one track length, and the standard distance of a track is 400 meters, so you might say they've gone 400 meters. But a clever person might actually take a look at this and see the person is right where they've started. They've ran in a circle, so they might say, well, they've actually gone 0 meters because they started where they ended. And it turns out that both of those answers are correct. And this is why in physics we have two different words to describe this, right? So on one hand, the person who answered 400 meters is actually describing their distance, and the person who answered 0 meters is describing their displacement. So another way of understanding this is displacement is the difference between where you start and where you end. Right? Only the starting points and the ending points matter, right, when it comes to displacement. Distance, on the other hand, is, includes the total path, right? So I'm going to go ahead and clear this and show another example of what I mean. So let's say we have particle A here. And particle A, right, goes like this and ends up, kind of travels in this roundabout path and ends up right there. Okay. And this green line here that I've drawn represents the distance that particle A traveled. So let me write that, distance. Whereas if I was to draw the displacement, which I'll do in red, and I'll do my best at drawing a straight line here, or not red, but brown. Okay, so we can imagine that's a straight line. That's displacement, right? Displacement's always the difference between where you started and where you ended in the shortest possible manner of getting there, right, which is going to be a line. And distance, right, includes everywhere you travel, right? So if you're traveling in a straight line, right, let's take a look at another particle over here. Let's take a look at particle B. Let's change colors. Blue here for particle B. And if you traveled in a straight line over here, right, well then distance and displacement would be the same, but only if you traveled in a straight line, right? And only if you traveled in one direction. Because, let's erase this. Or rather, let's get particle C, and we'll do particle C. Let's do actually in red this time, or pink maybe. And draw it over here. The particle C, who traveled like this in a straight line, but then came back. I'm going to draw this a little bit darker, following the same path, right? In this case, even though particle C is traveling in a straight line the whole way, right, the displacement is going to be 0, and the distance, right, obviously not 0. So distance and displacement can be the same, but only in a very, very special case.